All right, so both of these have been on unit exams in the past, to give you an idea of what I might ask as a vertical circular motion question. Okay, so for the first question here, we have a car that's moving at 32 meters per second. Okay, it loses contact with the road as it travels over it. So that means we're dealing with the outside on the top of a vertical circle. Okay, the car has a mass of 1,200 kilograms. Okay, and we're looking for the radius of the bump in the road. All right, so we've got gravity acting in, and what acting out? Nope, nothing. It was a trick question. Okay, there's no force acting out because the car lost contact with the road. Therefore, the road can't exert any force back on the car. So this is it. Okay, we just have the force of gravity acting in. All right, so give them a mark for givens here. Okay, we're going to calculate FC by going forces in minus forces out. So maybe they have that written somewhere, or maybe they went straight to this. FC equals FG. Okay, they can have a mark for that. All right, so what we have then is mv squared over r equals m times g. Okay, and we need to manipulate that for r. So I'm going to bring r over to this side, and then I'm going to divide both sides by m times g, which means the 1,200 kilograms didn't matter at all. We didn't need it. Okay, so 1 mark if they have it manipulated for r. So r will equal v squared over g. Okay, then we're going to plug in our numbers here. So we got 32 squared divided by 9.81. So they can have a mark for that. Okay, that's up to 4. Okay, 32 squared divided by 9.81. So the radius of this bump in the road is 1.0 times 10 to the 2 meters for their 5th and final mark. Okay, questions on that? Okay, and then we did one like this just the other day. Okay, we have a 75 kilogram fighter pilot. Okay, pulling out of a steep dive, which is like the bottom of a vertical circle. All right, so we're dealing with this point right here. I'm not going to try and draw a plane. It's a plane, but that's a car. Doesn't matter. Okay, that's the point in the circle we're dealing with. So at that point in the circle, our forces out will be gravity, and our force in will be normal force. All right, so give them a mark for givens. Sorry, I don't have them all written down here yet. 300 meters per second, and then g-force is 8.5 Gs. Okay, so give them a mark for givens. Give them a mark for a free body diagram on this one as well. Okay, so here's what we got. Forces in minus forces out. Which one's bigger, normal force or gravity in this situation? Normal force. It's got to be bigger, otherwise not moving in a circle, right? The net force has got to be in, okay? But in this case, okay, we have FC equals normal force minus the force of gravity. So they can have another mark for that. I think we're up to 3 now. Okay. If we're looking at this from this perspective, okay, what were we trying to find here again? We're trying to find the radius of the circle again. All right, so we got mv squared over r equals, how heavy do they feel? It says they're pulling 8.5 Gs. So they feel how much heavier than normal? 8.5 times. Okay, so we have 8.5 here. And how heavy they are? No, that's their mass. Right? They feel 8.5 times more than their actual weight. So that'd be 8.5 mg. How much is this? How do I calculate FG? Isn't that how I calculate FG? What's 8.5 mg minus mg? I have 8 apples. I subtract 1 apple. How many apples do I have? Okay, so this is 8.5 apples minus 1 apple is Okay, so mv squared over r equals 7.5 mg. All I have to do now is solve for r. Okay, so I just have to manipulate this to get r. So I'm going to bring r over to this side here. Okay, and then I'm going to divide each side by 7.5 mg. So the m's are going to cancel, and I'm going to have v squared over 7.5 times 9.81, or times g, sorry. I'll just write g for now. Equals r. So give them a mark for that. I think that's our fourth mark, right? Yeah. Okay, so plugging in our numbers here, we're going to have 300 squared divided by 7.5 times 9.81. Okay, so that was our fourth mark there, right? Okay, so we have 300 squared divided by 7.5 times 9.81. Okay, it's a big circle. It has to be. Plane's going really fast. If it takes too tight a circle, it'll kill the pilot. This would probably cause the pilot to black out. So, okay, we're looking at 1.2 times, actually no, 1.22. Here's why. That doesn't get used. That's not a measured value. It's a factor, not a measured value. So I'll let that one go, but our actual significant figure should be 3 on this one. Okay, 1.22 times 10 to the 3 meters for their fifth and final mark. Okay, so give them a mark out of 10. Let them see it, and then put them on this desk here in front of Cohen.